Hey everybody, it's Tony from Adafruit, and I wanted to do a stream on the Circuit Playground board and Firmata, which is a neat way to control it from a computer. So I'll show how you can actually use the Python programming language to control a Circuit Playground board. So to like light up the pixels or read the accelerometer or really do pretty much anything that you could do directly on the Circuit Playground with the Arduino IDE, but using like a high-level programming language like Python, and maybe even in the future you can use things like JavaScript, lots of different libraries that can talk this Firmata protocol. So let's just kind of dive in and we'll get started, and I'll kind of run through a bunch of demos of things, show off some code, and you'll see what you can do with Circuit Playground. So let's go to the main view right here. So here's basically web browser, and then up in the corner up here is Circuit Playground, and this board actually is one of the I guess it's upside down, but this is one of the developer editions. And if you're really excited about Circuit Playground, you'll definitely want to watch tonight on Ask an Engineer. That's 8 p.m. Eastern time on Adafruit, youtube.com/Adafruit. You can watch it live, or twitch.tv/Adafruit. And you might be excited to see what's going to be in the new product section. Maybe a little bit of a hint there that if you like Circuit Playground, check out Ask an Engineer tonight. So anyways, I've got the Circuit Playground board right here. It's connected to my computer. I should also mention this Circuit Playground, it's an early proto that kind of didn't really pass a lot of the testing. So there's a little red LED right here that doesn't work. When you're using your Circuit Playground, whenever it's powered on, you'll see a red LED. But hey, I got kind of the extras that maybe didn't have everything working. But everything else on this board works fine. So we'll see everything work. So that's Circuit Playground. And then over on the web browser here, so I'll mention this is the product page for Circuit Playground, and I'll put down in the description when this is on YouTube links to all of the different web pages I mentioned here, so you can go and check it out. But this product page, and it's not in stock yet, but like I said, watch Ask an Engineer tonight, and you might be excited about what you see. And if you aren't familiar with it, so Circuit Playground is kind of our all-in-one physical computing board. Basically, for the longest time, teachers, educators, even just normal people who want to get started with electronics, there's this really big hump you have to get over of, okay, you get a bag of parts, you solder them together, you wire them up, you load them up with code, and then you make them do things. And just getting all of those necessary skills is pretty difficult and a little bit daunting, especially to a newcomer, like someone who's never soldered anything before. So there's always been a lot of demand for just an all-in-one board, like Circuit Playground, where there's no soldering required, but it can do interesting things. You can take an Arduino, like an Arduino Uno, and just with nothing connected to it, it has an LED on the board, so you can at least light that up. But otherwise, there's not too much you can do. You're going to need to plug in some components, or maybe solder up some circuits to connect to it. So the basic idea with Circuit Playground is that it's an Arduino compatible, so it uses the ATmega 32U4 microprocessor. So same thing in like the Leonardo and the Flora. But it also has a bunch of components on it, and so the product page lists them all. And like watch Ask an Engineer tonight, and you'll see a lot more details about it. But it's got things like a ring of 10 neopixels around it. It has a little accelerometer, the LIS3DH, a very nice little low-cost accelerometer. So it can do things like it can detect which way gravity is pulling the board down. So you can do some basic orientation detection. Like is it tilted? Is it held in a certain way? You can also detect like is it being shaken? Is it moving around a lot? And then it can also do tap detection. So like if you tap the board, it can pick that up, and you can treat that as maybe like a button press to do something. Then it has some analog sensors. So there's a thermistor, which is a temperature sensor. It's basically temperature sensitive resistor. There's a light sensor, just a phototransistor. So both of those output like an analog. They change their resistance based on the things they're sensing. So as the temperature changes, the resistance changes. That's fed into an analog input on the chip. And so just with an analog read call in the Arduino IDE, you can basically get a value that's dependent on temperature. So things can change. And then there's also a little microphone, so also another analog input on here. So you can detect sound pressure and things like that. A couple push buttons, so left and right push button right there. And then there's also a slide switch kind of in the middle here, so you can move that in between two different positions, like on and off on there. And then you'll also see there are all these little inputs along the outside of the board, and it's very similar to Flora. So there's like pin 0 and 1 on the outside over here. Those can act as a serial port if you want, or they can just be general digital inputs and outputs. There's also pins 2 and 3 over here. Those can talk to an I2C device, so you have your clock and your data line, or they can also just be digital inputs on here, or digital outputs too. And then there's just some general ones, about 4 pins on this side that are exposed, and then there's like power and ground pins. And so all of these, they're really easy to connect like an alligator clip to. You don't have to solder to these. They're also good. You could make this a wearable project, so you could wrap some conductive thread around these and maybe tack it down with some solder, and you've got a cool thing to put on like a jacket or a shirt. And the neat thing is, because you've got like the NeoPixels on board and even some sensors and stuff, just this alone is a cool little wearable thing. You can imagine put it on like a jacket. I was thinking a fun thing would be just hot glue a magnet on here, like to hold a name tag on a jacket, and then you've got just a board ready to go. It also has a little power connector up here, so this is good for plugging in a lithium polymer battery. So you can plug in any like 3.7 volt battery, and the board itself runs off of 3.3 volts, so it runs at 8 megahertz, doesn't run at 16 megahertz, so it's just like the Flora board. It's made to be powered from either USB or plug in a LiPo battery, and it's ready to go with that. And then the other thing I didn't mention, all of those digital inputs and outputs, so there are 8 of them on the sides, those can also act as capacitive touch sensing inputs. And so it's just a real simple way. You use a resistor, and then the capacitance of like your finger touching one of these pins will change the time that it takes for a signal to change on one of those pins. So it's a real cheap and easy kind of way to do that kind of sensing on here. And so we'll go through and we'll do some demos of using all those components. Now, one way to use Circuit Playground is you can program it directly in the Arduino IDE. And so you can see you load up in the Arduino IDE, you add the Adafruit board package, and then you see Circuit Playground as a whole new board that you can pick, and then you can just upload code to. You can upload, the basic blink sketch, and that'll blink the red LED on here. You can upload, just anything that controls the components, like a NeoPixel sketch, for example. And that's cool because your code will run on the Circuit Playground. So, you can unplug it, you can plug in a battery pack, and, take it, it's portable, it's ready to go. But you have to use the Arduino IDE and the Arduino programming language. Which, it's a good way to get started, but like I mentioned before, there's always just everyone is at a different level, and so some people maybe aren't as familiar with like C and C++ kind of style of programming that Arduino uses. You might be more familiar with like Python or higher level languages that are a little easier to use. And so that's where Firmata comes into play, and why I think it's so interesting. So Firmata is a protocol, and I'll put a link to it. This is the GitHub repository that kind of has all the main information on it. And I've done a stream on this before, actually, when I first started to do some of the Firmata stuff with Circuit Playground. But now that it's pretty much getting ready to release, I figured I'd do this follow-up stream to go through it in more detail. But anyway, so Firmata is a protocol that you can talk over serial connection, so like the USB to serial connection on the Circuit Playground board right here. And you can use that serial connection to control your Arduino board. So pretty much anything you can do in the Arduino IDE, you can do with this Firmata protocol. So your computer that's connected to Circuit Playground through the USB port, it can run code that can talk the Firmata protocol to the Circuit Playground board, and it can control the board. And so the basic Firmata sketch, which you can load on any Arduino, so load up on like an Uno, Leonardo, even a Flora, I would bet, could probably run it. You can load up the Firmata sketch, and then you can do things like have code running on your computer that says, okay, set pin 10 on the side as a digital output and set it to a high level so that, maybe it turns on an LED. Or maybe take pin 3 on this side over here and make that a digital input, and tell me when it goes to a low value so that, when I see a switch is pressed, then I know something happened, and, my code on my computer can act accordingly. So, it's pretty powerful in that your computer can control Circuit Playground using any programming language that has a library that can talk the Firmata protocol. And the cool thing is, in this Firmata page, they kind of mention there are a lot of libraries that can talk the Firmata protocol. So like processing, which is more of a Java style language, that can talk to it. Python, Perl, Ruby, JavaScript, Java, .NET, pretty much every language has some kind of a library you can use to talk the Firmata protocol. So that's the basic idea with Firmata on Circuit Playground, is that you want to be able to write code on your computer that can control Circuit Playground and do it in a higher level programming language that's maybe easier to get started with and to learn from. And then, so one thing that I did though, it's not enough, I think, to just use the standard Firmata, which lets you like do basic digital and analog inputs and outputs. You really want to be able to control the components that are on the Circuit Playground board. Like you want to light up the NeoPixels, or you want to, maybe use the little buzzer. There's a little speaker on there to make tones and music and things like that. So I made custom extensions to Firmata. I made a special version of the Firmata firmware just for Circuit Playground that added some extra commands. And so the Firmata protocol has a way that you can extend it. It has a concept called system extensions. So you can add your own commands to the language. Excuse me. And then that way you can, take a Firmata library, and as long as it supports sending and receiving some of these custom commands, which pretty much all of them do, because it's, the Firmata protocol itself is just built on these low-level kind of commands, these system extension commands. So as long as you can talk these custom commands, then you can control the components on the board. So you can light up the NeoPixels, you can read the temperature values from the thermistor, read the light levels from the light sensor, that type of stuff, or read the capacitive input buttons, see if something's pressed or not. And I've actually created a little Python wrapper so that you can just get started right away using some Python code to talk to the Circuit Playground board and control it so that with just a few lines of Python code you can light up NeoPixels, or maybe make them sound reactive so that, like, as you hear a higher level of sound pressure from the microphone, maybe you light up more NeoPixels or something like that. So it's meant to be a really easy way to just get Circuit Playground, plug it in, load up a little firmware, and then start loading up the Python code and hacking away at it, and making things work without getting over all those humps of like soldering a bunch of components together and learning enough C code to get it programmed on the Arduino IDE. It's meant to be a little bit easier and a little more straightforward to get started with. So let's just kind of dive in. I figured in this stream I just want to kind of capture the basics. So there's a learning guide that'll be published probably tomorrow or maybe even today, and this video will be in it, but it walks through all of these steps in kind of detail and text. But I wanted to have this video to also show here's what to do. So to get started, first of all, you want to set up Circuit Playground in the Arduino IDE to be able to program it. So and the main Circuit Playground guide will go through this also, but I'll just show real quickly. It's actually a little bit easier than you might think. These days, make sure you're running the latest version of Arduino. So I'm using 1.6.7. I think maybe there's 1.6.8 out, but as long as it's past version 1.6.4, that's the one that added a lot of really fancy new good stuff. So in the Preferences menu, and by the way, this works on all operating systems, Windows, Mac, Linux, you're good to go. But anyways, go into the Preferences, and this Additional Board Manager URLs is where you want to drop in this special URL here, and I actually have two of them. So I have this first one is the Adafruit URL, which goes to this GitHub page, and then I have a comma right here, and I have the ESP8266 board. But you just need this Adafruit package board URL here, and it's mentioned in this guide right here. If we scroll down, you want to copy this in, and then once that's in, you want to say OK, and then close out and reopen the Arduino IDE just to make sure that it reloads it, because sometimes it doesn't reload it. But once you do that, then go into the Tools Board Manager, and then let it kind of run. You'll see it downloads a bunch of things in the background here, and what it does is it goes to that board package URL, and then if you scroll all the way down, you'll see there's a whole new package on here. So there's the Adafruit AVR boards package, and you want to install this. I've already got it installed, but install the latest version of this, and then again, just to be safe, close out of the Arduino IDE and load it up again. It might load the boards, but sometimes it's just easier to reopen it. And then you'll see when you go into the boards menu, now I have a whole bunch of other boards, but there's this Adafruit boards list here, and look at that, Circuit Playground is right there and ready to go. So you want to pick that, and then I've got mine and plugged in, and like I mentioned before, it's not the red LED, there's a green LED right here that'll normally be lit up when you're plugged in, but like my board's a little bit of a proto one. But anyways, so mine's plugged in, and you should also see under the port menu, you want to pick the serial port for the board. So I'm on a Mac, and the convention is kind of this USB modem device is what it shows up as. I'm not sure why, but it might be an El Capitan thing. Usually you'll also see right next to this Adafruit Circuit Playground, because it looks at the USB vid and PID, but sometimes, like maybe on the latest versions of Mac, this might not work correctly in Arduino. But anyways, you want to look for this. Now on Windows, I should mention, you also have to install a little driver, and we have a little all-in-one driver installer package. So look in the Circuit Playground guide, and it'll show you a link to the driver install. But on Mac and on Linux, you should be good to go without any driver install. So once you've got that set up, you should see your serial device. On Windows, it'll be a COM device like COM1, COM2, something like that. Looks like this USB modem device. On Linux, I believe it shows up as dev TTY, maybe USB, either USB or ACM, one of those devices. So, and if you're not sure, the easiest thing is unplug the board, go up to the board list and see what it lists, then plug the board in and go back to the board list, and you'll see a new thing listed there, and that's probably Circuit Playground because it shows up as a USB serial device. Anyways, though, okay, so I've got it loaded up. Always smart to just do a basic blink sketch and just make sure you can load something on the board. So I'm going to go into example basic blink, and the basic blink example you can just load as is. So it's going to blink pin 13, which is a little red LED on the board right here. So I'm just going to do tools upload, just press the upload button, and it's going to upload to the board. Now it might fail because this might be another little El Capitan thing. Okay, looks like it's working. So you can see it just loaded to the board, and now look at that, the red LED is blinking. I'll also show you if you ever get a failure during upload, like it says, maybe it can't talk to the board or something. One quick thing to try, there's a reset button right in the middle of Circuit Playground. Double tap it, so press it twice, like you're double clicking, and you'll see the red LED starts pulsing like that. So that forces it into the bootloader mode, and then do the upload after you do that. Now it only stays in the bootloader for like, 10 seconds or so. So I'm going to do it real quickly here, and then let's see. Oops, I missed it that time. There we go. So I did it, and then I'm going to do upload, and this will also work. So this just makes sure, in case there's this weird little port knock thing that kind of has to happen where it opens up the serial connection at 1200 baud. And sometimes I've noticed, especially with OS X El Capitan, it has a whole new USB stack that's kind of wreaked havoc with a lot of Arduino boards. But this is always a surefire way to force it into the bootloader and let you program it. But anyways, okay, cool. So I can program this board. Now to use the Firmata Python code, so first you're going to need to load up the Firmata firmware sketch on the Circuit Playground board. So these developer edition Circuit Playground boards, they don't ship with Firmata code running on them. Maybe later boards we might actually ship with Firmata code running on them. But for now you need to load up the Firmata library. And before you do that though, so I'll put a link to, so like here's the GitHub repository that has the Firmata sketch that we need to load, and it also has the Python code inside of here. So we'll come back to this, but before I can load up this sketch, I need to install this Adafruit Circuit Playground library. So this is basically an all-in-one Arduino library that has all of the different sub-libraries that we use. So it has the LIS3DH accelerometer, the capacitive touch sensing, NeoPixel library, basically some of the dependencies. We put it all into one library because that's another bit of a stumbling block with Arduino. It's gotten a lot better as far as installing libraries, but as a newcomer, it's not very obvious sometimes of like, oh, I want to upload this sketch, but it's telling me I don't have the NeoPixel library. What do I do now? So, you need to know to go and install all these libraries. And so we figured, well, let's at least just, you're going to have to install one library at least, and let's put everything into that library. And yeah, it duplicates code a little bit, but in this case, I think it makes sense because these libraries are pretty stable. So this Adafruit Circuit Playground library is what you want to install. Now, this is actually really easy in the latest versions of Arduino. So you want to go into the Tools menu, the Sketch menu, and Include Library, and then Manage Libraries. And this brings up the library manager, and it'll run for a second, it'll download. So there's a little online package manager system now with Arduino. And you just want to type in Circuit Playground, and you should see that it comes up, just type in Circuit. It's actually Circuit space Playground. And you'll see this top one up here, Adafruit Circuit Playground. And so I have this installed, but if it's not installed, there's a little install button that you want to click. Click install, and then just to be safe, restart the Arduino IDE to make sure that it loads up the new library. But this is all that you need, and then once you have that installed, you can actually see under the examples, you should see Adafruit Circuit Playground as a library, and it's got a couple demos. So I actually included, there's the Firmata firmware as an example in here, and it's perfectly fine to load this code up. You can use this, but like I mentioned, I have a separate repository that has the Python demo code in it also that you probably want to grab. There's also a little demo sketch here, so I'll just load this one up also to just kind of show what you can do with it. So we'll just press upload on here. And this little demo just kind of lights up all the components on the board. And, you know, this is a good demonstration of, like, you know, Firmata versus programming the board directly. So, oh, and actually you can hear it plays a little bit of music on the buzzer. So, and if I slide the slide switch, it will stop the music. There we go. So, but this is, you know, code that's running on the chip and controlling it. You know, I can unplug it from USB and plug in a battery, and it's going to do this exact thing. But, you know, Firmata would be basically my computer running and controlling the board to do this stuff. And so if I unplug this from my computer, the board's not going to work anymore. Like, it needs my computer to be running and telling it, you know, animate the neopixels or turn on the buzzer or things like that. So just a little bit of a limitation and difference there. And, you know, I think the trade-off is good, though, in that as you're learning to program, you know, you can start with a high-level language like Python, get familiar with hardware and things like that. And then when you realize, like, okay, I want to make this thing portable, you know, I want to plug in a battery and make this thing go, then start looking at the Arduino IDE and how to convert your code to run on the board directly here. Okay, so you've got the Adafruit Circuit Playground library installed. You've got the Arduino IDE set up to program the board. So now you want to grab the Circuit Playground Firmata repository and download the code for this. And there are two things in here. There's the Circuit Playground Firmata sketch, which is also included in the library. You can use either versions of these. So this is just the Arduino sketch that we're going to load up on the board, and then some Python example code that we'll go through and look at how it works. So I'm going to open up this sketch in the Arduino IDE. So let's just open up, and yeah, I've got it here already, actually. So there's the Firmata sketch. Now there's nothing that you need to change in this sketch, and if you look through it, it's actually pretty complex. It has a lot of logic in here. This implements all of the logic of, you know, listening to that serial port, waiting for your computer to send it some data to say, okay, you know, do this or do that action, and, you know, it's ready to go. So it's a good sketch to just look at, but don't worry, you know, don't freak out when you see all this code here. It's like, oh my God, how am I ever going to understand this? This code is complex to hide all the complexity of the Firmata code that you'll see later. So all we want to do is upload this to the board. So I'm just going to make sure that I have the board selected. Yep, we're all good there, and I'm going to press upload, and it's going to upload it to the board. And we should see, once it finishes uploading, everything will turn off. So by default, it goes into kind of a default state. Oh, so here you see it ran into a little problem uploading the board. So when this happens for me, I just double press the reset button. Now the red light pulses, and now I'll do the upload, and this should go. And you need to make sure to do it kind of quickly because, you know, after 10 seconds the bootloader stops and you'll have to do it again. So okay, so that worked. And you can see everything kind of turns off. So the default state with the Firmata firmware is that it's waiting for something to tell it to do something. So, you know, it's not going to turn on the neopixels, it's not going to play any music or anything like that. So okay, so we're running Firmata, and at this point we're actually done with Arduino IDE. Like, we can close this thing out. We don't need to use it anymore to talk to the board. Okay, so now we want to play with the Python code that's in here, and we'll run some of the demos in here. So, you know, again, make sure that you download this repository, and there's a Python examples folder in here. And so we need to go in here and start playing with some of the data. So I'm actually in this directory right now, or actually I'm in the Firmata directory. Oh yeah, here it is. So we'll go into the Firmata Playground, Circuit Playground Firmata directory, and then go into the Python examples directory. And before you get started, there's one little Python library that you have to install. So first, like, make sure that you install either Python 2.7 or 3.4 or 5. I think the current version may be 3.6. You know, install the latest version of Python. You can use either Python 2 or 3. I've made sure that this works with both. So you're good to go. And actually, I was thinking, let's use Python 3 for this example. Now I'm using Mac, and because I wanted to use Python 3, on Mac you probably want to install Homebrew, which is like this little package manager system. And then from Homebrew you can do brew install Python 3, and this should install Python 3 on Mac, because by default Apple I don't think actually ships Python 3.0. So, and you can just double check, like if you type Python 3, this will run the Python 3 interpreter. But it's perfectly fine if you just run Python and use Python 2. This will work also, so either version is fine. On Windows, you know, there's usually an installer that you want to run to install Python. And then after you install Python, you also want to install the pip package manager, PIP. And I think the latest versions of Python, I think, include pip by default. So, like, just try typing pip, and see if you get some help back. If you don't, then you might need to manually install pip, and I'll put a link down in the description. But if we go to like Python pip, they have a little install page that kind of mentions how to install it. So the right way to install it, you download this getpip.py file, which is the Python script, and you just run this with Python, and then that will install the pip manager, and then you can use the pip command to install things. So once you have that set up, then you want to do pip, and because I'm using Python 3, I'm going to use pip 3, which is the version of pip for Python 3, because if you have both Python 3 and 2 installed, you actually have two versions of pip that you need to worry about. But pip install Pymata, P-Y-M-A-T-A, and this is the Pymata library, and I've actually already got it installed, so it didn't do anything, but normally you'll see it goes through and installs things. And so the Python examples, they're actually written using this Pymata library that I talked about in an earlier stream that I'll put a link down in the description below too, but really nice little Python Firmata library. It does, almost all of the grunt work of talking to the Circuit Playground Firmata firmware, and then I've just added my little extensions on top of it. So okay, cool, we are good to go at this point. So I've got the Python example code here, and I'll just kind of run through, just briefly mention all the files. So all of the .py files in this directory are examples, except for this Circuit Playground.py file. So this is the little helper class that the other files use, and so it creates a Circuit Playground board class, and then has a bunch of functions on that class. Like there's a set neopixel function, and you tell it which neopixel to light up and what color to make it, and then it'll go and it'll send the Firmata command to the Circuit Playground board automatically for you, so you don't even have to know or care about how the protocol works. You just have a Python object and you say change the color, or it has read the thermistor temperature, and it'll give you back the temperature in degrees Celsius, and you can use that and show it, or maybe change your actions based on that. So it does all the work of talking the Firmata protocol for you using that Pymata library. And if you want to write your own code, you can actually just copy this circuitplayground.py and just put it in the same directory as your code, and then your code can reference it just like these example files do, and you can use it and write all kinds of cool fun sketches and programs and things. So okay, so there's Accelerometer streaming.py. These show off using the accelerometer, so they'll just give you the raw XYZ axis acceleration readings. So like I mentioned, kind of good to check, like, is the board tilted? Because the force of gravity is always constant. It's going down 9.8 meters per second squared. And so you can kind of tell, like, okay, when the board is held in this orientation, the down axis is the z-axis, and so I should see the z-axis as 9.8 meters per second squared. But when I hold the board in this orientation, now I think like the y-axis is the up and down axis, and so now that axis is 9.8 meters per second squared. So, some basic ways to sense how is this thing being held just using an accelerometer like that. So that's what those demos do. The button demo, this just demos when you press the buttons, it'll print out a message to say, hey, this button's been pressed. Real good simple demo of showing off the buttons. Cap streaming and cap touch, these show off using the capacitive touch inputs on the side. So like, if you press something, it can pick that up as a touch on here. Light.py, this looks at reading the light sensitive resistor on here. So you can cover it and it'll get darker and you'll see a lower value, or you expose it and it gets brighter and you see a higher value. Pixels.py, this will light up the neopixels, so it just animates lighting all the pixels around here. Sound.py, this will just read the microphone on the board and it'll just give you the raw samples for that. So it's just a simple demo of getting sound data like that. Tap and tap streaming, these listen to the tap detection on the accelerometer. So when you press it or double press it, it can actually pick that up and tell you about it. And then temperature, this reads the thermistor and then prints it out. And tones.py, this will use the little piezo buzzer, a little speaker on the board that can play basic tones. So do like it's a square wave, so it's not the prettiest sound, but you can do you can make notes and it does a little scale of things. So let's dive in and see what we can do. Let's play some of these demos. So I want to start with the buttons.py because that's a real simple one of just pressing the buttons. And to run all of these demos, you want to run Python, and I'm going to use Python 3, and then you have to give it a command line parameter that's the name of your serial port. that the Circuit Playground is connected to. And if you aren't sure, go back to the Arduino IDE, go to that port list under the Tools menu and find the port under there. On Windows, it's going to be a COM port like COM1. On Mac, it happens to be, for me, this dev tty.usb modem. So that's what I want to use. And that's all you need to do is just specify those two parameters and run this. And it takes it oops, actually I just realized I have a typo in here in the file name, so let me remove this extra slash. So you'll run this, and then basically it's going to open up the serial port here, and it's going to start talking to the board. And in just a second here, this should work. Although I wonder if I might have just messed something up with running it. Let's see. We'll see if this is running. I might fall back. We might use Python 2.0 if Python 3 is doing something weird. So let's see. Let me try. Let's see Python dev tty USB modem. And this should open it up. And let's see if this works. Although I might have done something funky. This is always the danger of live demos. We might have some live troubleshooting here. It's funny because you test these things out right before you start streaming, and it's like, oh no, something doesn't work now. Interrupted system call. Well, I hit Control C, so that's a little weird. I'm not sure why it's not opening up the port here. Let me just close out. Just open a new session just to make sure I didn't mess anything up on the terminal session that I had. So let's do a new window here. Let's bump the size up a lot, and let's go into the Circuit Playground, Python examples, and let's see, I'm going to unplug and plug back in the board, so we're good there. Okay, now let's just double check the serial port. Okay, let's see if there are any other devices here. So okay, yeah, so we've got that. Okay, let's try this again. Let's do Python 3, just make sure that runs. Yep, that's all good. Python 3, oh, I just realized what I was doing. You need to give the file name to run. Python 3 buttons.py. So that needs to be the first parameter, and then you want to give as the next parameter the serial port name. So dev tty.usb modem. So before I was just giving this dev tty. So Python was trying to open the serial port and then run whatever it saw as Python. So no wonder it was a little confused. Anyways, okay, so now we're running, and it takes a little bit of time. It takes about 10-15 seconds to start up, so it'll open up the connection to the board, and it'll initialize. It'll do some. It'll talk to the Firmata firmware and figure out like how many digital inputs do you have, stuff like that. But now it's ready to go. So it says, okay, press the left button, right button, or the slide switch. So if I press the left button, you see, or this is the right button because the board's upside down relative to me. So it says right button pressed, and then I let go, right button released. And then the same thing with the left button, pressed, released, press, release. So that's cool. You can get a notification of both of those. And then the slide switch, if I move it, it's on the right, it's on the left now, so you can pick up both those actions. And we'll look at real quick, I'll just show the code for these as I go through them, really briefly. So in this editor, this has open the Circuit Playground Python code directory. And the code for this, so basically the first line here, I'm just importing the circuitplayground.py file. So that, like I mentioned, that circuitplayground.py, that has all this little helper code that can talk the Firmata protocol. Then I just check and see, did you pass in the serial port as a command line parameter? So nothing too crazy there. And here I create an instance of that Circuit Playground class that I mentioned, and I just need to tell it the serial port that I'm talking to. And for the buttons, the way that I'm using them is actually just using the standard digital read functions in the Python library. So it has a digital read where you can say, okay, set up these pins, and I mentioned right here the left button is digital pin 4, the right is pin 19, and the slide switch is pin 21. So set those up as digital inputs, and you can also pass in a callback function. So when the values change, your function will be called. So I have one for the left button, and this is called whenever that button changes. Like when you press the button, it's going to change. And the way these push buttons are set up on Circuit Playground, they have a pull-down resistor. So normally they're at a low level, a ground level, and then when they're pressed, they get pulled up to the 3.3 volt level, so they get pulled up to a high level. And that's kind of nice. In your code, you can have a simple if statement that's like, if digital read pin 4, if that's true, then the left button is pressed right now, basically. So that's why you see in this code, because sometimes when you use buttons, you might use a pull-up resistor, because those are actually natively built into the Arduino microcontroller. But then your logic has to be inverted to say, okay, if it's not at a high level, then it's pressed, which gets a little confusing. So that's why we made these pull-downs instead of pull-ups. But anyways, so you can see this function, it's called whenever the level changes, and it's just inside of this data parameter that gets passed to it that actually has the current logic level. Is it true or false? So is it a high level or low level? So you can see if it's at a high level, this evaluates to true, and it just prints out left button is pressed. If it's not at a high level, then it's at a low level, and so the left button is released. And that's pretty much all the logic that it has. So same thing for left and right buttons. And then the slide switch, it's when it's on the left, it's at a high logic level, and when it's on the right, it's at a low logic level, and just prints out accordingly down here for that. So, and the nice thing is, because these are callback functions, they're actually run in a separate thread, I think, that Python has. So whenever they change it, this code will run. And so I just have a main loop here that just sleeps just for every second. So it's just waiting for these callbacks to run. But you could be running your own logic in here. You could be having like pixels animate or things like that. And then when someone presses a button, you could update some global variables that maybe change how your pixels animate or something like that. So, very simple, straightforward kind of code. And I do believe, I haven't used it much myself, but Python also has just a simple, more, because this is like an asynchronous style of you give it a callback function and that callback is called whenever something changes. But I'm pretty sure they have just a digital read function that's the equivalent of you call it and then it'll return back the current state. Now the annoying thing with that, unfortunately, is that you're going to have to constantly pull the board, which means you're going to have to constantly ask it, okay, digital read, what's pin 4, is left button pressed? And then immediately again in your loop, you're going to say digital read is left button 4 pressed. And so that's going to send out a command over the serial port. There's a little bit of latency involved with that, so it's not the quickest thing. So that's why a lot of this code uses these callbacks, because basically we tell the Firmata firmware, hey, I'm waiting for some event to happen. When it does happen, immediately send me a notification of that, and then my code can run, so that I don't have to constantly ask, is this done? Has this happened yet? The board's going to come back and tell me when it happens here. So it's a little bit different than sometimes you might see in some programs here. But okay, so that's the button example. So then I'll just press Control-C to stop that one. So that's pretty cool. Let's move on. Let's run a NeoPixel example. So let's run, we'll do Python 3, the pixels.py. And again, I have to give the serial ports. And this time I remembered I give the script to run also pixels.py. And so again, this does a little bit of setup. Takes 10-15 seconds or so here. And then once it starts running, you'll see that now the pixels are animated. So that's kind of cool. And they're kind of moving around in a little rainbow here. And it'll do it for 10 seconds, and then it'll stop. And we should see in just a second. So yep, it just stopped. So that's cool. And I'll show you the code for this one. So it's really not too crazy. So at the top, it's pretty much the same boilerplate that you saw before. Import the Circuit Playground helper class, do some command line parsing, just get that serial port name, and then create your board instance here. And then here, I'm basically I'm setting up a little lookup table so I can quickly look up, what are the rainbow colors that I want to iterate through. So I just make a little table here, and you can just tell these are all 24-bit colors. So there's a red, green, and blue component with values from 0 to 255, where 255 is like bright and 0 is low intensity. So red is like 255 on the red component and 0 on everything else, whereas yellow is red and blue, or red and green as max intensity, and then 0 on your blue intensity. So it's basically like HTML colors. You can use an HTML color picker, and as long as it gives you these values here, and you can actually put in hex if you wanted here. Put like this could be instead of 255 OX55 or OXFF, and that's the same thing as 255. But anyways, so I make a little lookup table. Now I call this board.setPixelBrightness 50. And so this is a way to control the brightness of all the pixels. So let's change this. Let's make this 100. So this can be a value from 0 to 100. And if I rerun this, we should see that it gets a little bit brighter. And so this is a good way, if it's a little too bright, you can knock down the brightness with this. One thing to be aware of, though, is this is just like the set brightness function in the NeoPixel library. So now you can see, especially on the camera, and it auto exposure, so it just adjusted down the exposure, so it might not look as bright as before, but it is actually a little bit brighter than last time. But anyway, so this pixel brightness, now a lot of people think like, oh, I want to animate like pulsing neopixels on and off, and so I'm just going to animate going from like 100 to 0 to 100 again brightness. But the problem is when you go all the way down to 0 brightness, you actually lose all the color data, because we try to do some optimizations to apply the brightness as it writes out the pixel data, and like we update the pixels, and so when you go down to 0 brightness, you lose the color data, and when you try and go back up to a higher brightness, you just get like white pixels again. So the set pixel brightness is not really meant for animations. It's meant more for do a one-time little setup of like oh, it's too bright, knock it down to 50% brightness. In some cases maybe you want to change that brightness. Like you could periodically change the brightness, but just realize if you go down to 0, or even if you go up to 100, I think in some cases you can also lose the color data and get like pure white pixels. So as long as you stay away from those extremes, you can do a lot with it. But anyways, so I set the pixel brightness, and then I just have this loop here. And really the meat of this loop is the board set pixel function. So this just takes the number of the pixel to change. And so I loop through all 10 pixels on the board. And then I do like some fancy math here to look up which color I should use. And I just use the modulo operator so that I'm always looping through this list of colors here. And then, I'm basically iterating through each of the pixels, and it picks, a different color in this range. But set pixel is all that I call, and I just say which pixel to change. So 0 to 9, that's the 10 pixels, and then give it the red, the green, and the blue component values, so just 0 to 255, and that'll set the pixel. Now that only sets the buffer in memory. It doesn't actually change that pixel. You need to call the show pixels function to actually update all of the pixels. So that's kind of a convention where if you want to do like fast animation, you don't probably want to be constantly writing all those pixels out to the board. You want to change all your pixels, write them out to the board, then change all your pixels again, write them out to the board. So that's kind of why we split it apart, and why we have two separate functions for this. So this kind of shows, here's a good way to animate pixels. And then there's also a few little helpers. There's this clear pixels function that just turns all the pixels off. But again, you have to call show pixels after you use this one. And then we just close the board after that. So real simple. I mean, it's nice and easy. And you can see this Python code is very simple and easy to read. I maybe made this example a little more complex than I needed to. Maybe in the future I'll add some even simpler examples. But really just set pixel and show pixel is all you need. And you can have loops and do all kinds of animations. You can maybe read other sensors, like read the temperature sensor, and maybe change the color of the pixels based on that. So lots of cool things that you can do with this. So that's the pixel.py example. Let's see. Let's look at another example. So let's play with how about the accelerometer. So now there are two accelerometer demos that I have here. There's accelerometer.py and accelerometerstreaming.py. So I'll just run the first one, accelerometer.py, and we'll give it the serial port again. And let's see, we'll run this, and what this will do is every 2 seconds it will read the current state of the accelerometer, and it'll print out, here's the x-axis, the y-axis, the z-axis. So you can see right here, here's x, y, z-axis, and here's the current value. Now the units for these values are in meters per second squared, which is a pretty standard acceleration unit. And so this is cool. You can actually see my z-axis is reading pretty much bang on 9.8 or 9.7, 9.81 meters per second squared. And the z-axis, like I said, and you can see it's printed on the board. There's a tiny little bit of silk screen here that shows, z-axis goes up. Let's see, what are the other axes? So it looks like the y-axis goes this way, and then the x-axis goes kind of this way, the way it's oriented right now. And so this makes sense then. Basically gravity is pushing down on this z-axis, and we see that 9.8 meter per second force. Now if I tilt the board, so now the y-axis is facing down, now we see the y-axis is negative 9.37, or here we go, 9.8. So it's pretty much facing straight down. And that's just because like if I flip it around the other way, now we'll actually see, now it reads as 9.5, 9.8 meters per second. So it's negative because I flipped it around a different way here, but that's pretty cool. We're seeing exactly what we expect. And the other axes, they see a little bit of movement. And that's because like my hand is kind of shaking these around a little bit, and so you'll get a little bit of noise there. But if you just want to detect like is this thing facing like flat on a table, or is it facing held up like this, or I should even be able to see if I hold it this way we should see the x-axis, or no, sorry, let's see, how would the x-axis work? So I think this way is how I'd want to hold it to get the x-axis. Yeah, there we go. So 9.8 meters per second down like that. So that's pretty cool and pretty powerful. I mean, you can do a lot of neat things with an accelerometer there, and they're typically kind of scary components because there's a lot of math involved sometimes, and as you get into like 3D things like this, but just doing basic stuff of figuring out it, even if you want to detect like, is it at a 45-degree angle, you can check and see like, okay, now my z-axis is a little bit less than 9.8 because it's not getting the full force of gravity, and now my y-axis is a little bit of force going that way. So you can even detect little things like that. So that's cool. So that it'll print every 2 seconds the value. Now let's run accelerometer streaming.py, and I'll show you the difference in this one. And it's a little bit faster to update. So this one is actually just going to print out those XYZ axis acceleration values as fast as it can. And it's actually like once every 20 milliseconds it's taking a reading, and it's pretty quick. So you can see now when this runs, it'll spit out the data for a while, it'll pause for 5 seconds, and then it'll spit out the data forever in a loop. That was just because I wanted a good way to test turning on and off this streaming. But you can see here, so now it's like pretty much updating in real time. So like if I flip the board over, now we see like negative 9.8-ish or so on the z-axis, and I can hold it up and down like this, and everything's kind of changing. So this is cool. Like if you want to do fast animations of things, you're going to want to stream data really quickly like this. And so I'll stop this program and I'll show you the differences in these sketches or these Python programs. So here's accelerometer.py. Again, same boilerplate, create the Circuit Playground board, send it to serial port. And then this one's pretty straightforward. So the magic function is the board.readExcel function. And you actually pass it a function. You pass it a callback function that's going to be called when the XYZ data is received from the board. And so it actually parses it out and just sends you the data as the parameters here. So you get an XYZ parameter. And right now I'm just printing this out, but you could go and like change the NeoPixel colors or do all kinds of crazy stuff in here. But you can see, I'm just calling this every 2 seconds. So I call readExcel, then I sleep for 2 seconds, then I come back and call readExcel again. So this is a good like one time, you call this function once and it'll call back when it gets the data back from the board. If you just want to do a quick little reading of how is my board oriented or what kind of forces do I see. The problem is though, you're constantly going to have to call this readExcel, which causes a command to be sent down to the Firmata board, the Circuit Playground board, and there's some overhead with that, so it takes a little bit of time. So when you want to do things quickly, the accelerometer streaming.py example is what you want to use. And so this actually uses a couple other functions. So there's a start excel function on the board, and you pass the same callback that gets called with the data from the accelerometer, the XYZ axis. And so when you call that, that's going to actually tell the Firmata board, okay, start sending me accelerometer readings as fast as you can. And it's actually every 20 milliseconds it'll send a new reading down to you. And I think you can actually change that. I think there's a Firmata command. It uses the same polling frequency as the analog input reads. So with Firmata boards, you can turn on analog streaming of data where it'll constantly tell you the analog inputs values, and it uses the same polling time for that. But anyway, so you tell it, okay, start accelerometer, start streaming the data back to me, and now this callback function is going to be called every time there's a new reading from the board. So every 20 milliseconds or so, this will be called, and that's why you see it just printing out constantly here in the output console. So that's a great spot when you want really fast updates. Put your logic in there, and you don't need to worry about calling, read the acceleration. Just call start excel. There's also a stop excel, which you can call. That's just going to turn off the accelerometer. And then I just go into the loop down below here where I call start excel, and I'm just sleeping, I'm just doing nothing. And then in the background, that excel data function is being called for me. And then I try and be smart, so in a finally loop, or in a finally clause, I say, stop the accelerometer. So if I press Control C, then it's going to stop the accelerometer. Now, one thing you might want to do though, anytime you use these streaming functions, the board is pretty good about resetting itself so that when it's plugged into the serial port, it will automatically turn off any streaming that it was doing before. But sometimes, especially with the analog inputs, like when you read the light sensor or the thermistor, I've noticed the Firmata firmware kind of keeps that data being sent through the serial port, and that'll confuse the Firmata code when it connects again. So I'll show you what I'm talking about. Let's run the light sensor example, light.py. So let's do Python 3 light.py, and then the serial port tty.usb modem, and we'll see this might connect or it might fail. We'll see what happens, and I'll show you kind of the issue and how to get around it. So it's going to connect, and okay, so now it's printing out the light sensor values. So I didn't run into the issue now, but I'll show you after I run this again. And so basically every time the light sensor changes, it prints out the new value. And these values, they don't really have any units. It's not like lux or something like that that you can, evaluate to. But you'll see if I cover up the board, they get really low. And actually, this only sends data when it changes. So right now it's at 0, and so it's just stuck at 0. But when I take my hand off of here, it goes back up. And if I turn on like this light up above here, then you see it gets even brighter like that. So, pretty cool that you can detect that. So it's an easy way in your code. You can look at like, okay, maybe I want to scale my NeoPixel color based on the intensity of the light sensor, for example, like make a light sensitive thing with that. So a really cool thing you do. But I'm going to press Control C, so that exits out of Firmata. Now the problem is the board is still sending this data down the serial port, because it didn't get anything to tell it like, hey, stop sending data, I'm not using it anymore, because I basically just killed the serial connection. Now if I try and run this again, watch what happens. You'll actually see you get a weird little error from the Python library, and that's basically because it's getting confused as soon as it connects. So you see this index error list out of range. As soon as Firmata tries to connect to the Firmata board, the Firmata board's just saying, oh, hey, I'm going to start sending you all of this light sensor data, whether you want it or not. And the Python library is not ready for that yet. It's looking for more of this initialization stuff. So it gets it really confused, and it fails with an error like this. So what you want to do, the easiest fix is just unplug the board. So just unplug it like this, and then plug it back in. And what that'll do is that will reset it. You can also press the reset button on here, and that'll reset the code. But you might trigger the bootloader, so the red light might pulse. You might need to wait a second. But either way that'll work. Then it'll be back in a good default state, and now I can run the code again, and we should see it connect and work. So it's just a little bit of a quirk, and it's something maybe over time we might be able to find some ways to fix this. But it just comes back to the root kind of thing of, it's your computer that's running and controlling this board. And so if the computer tells it to start sending serial data or sending, light sensor data, the board's going to keep doing that forever until the computer tells it to stop. And if I just quickly exit the program by pressing Control C, that didn't really give a graceful shutdown to the board. It didn't, my computer didn't go tell the board, okay, I'm done, stop sending me data. It just closed the connection, and the board's still sending that data. So basically just smart idea as you run these examples to just unplug and replug in the board. And you can write code to detect this. Like you could have kind of like I had in the streaming example. So like this accelerometer streaming example is a little bit smarter, and you can actually Control C stop and then run this again, and it'll be okay, because it catches in this finally clause here when you press Control C, and it actually stops the accelerometer from streaming. So you could do the same thing. I don't do it in the light sensor example here. So here's the light sensor code. And this is actually using just standard Python functions. So I set an input as an input, but as an analog input, and it just so happens analog input 5 is the light sensor, and it gives you give it a callback function, which I call here, and it just prints out the raw light sensor readings. But you see I don't have like that finally clause to tell it to stop using this as an input. Maybe something smarter I should add in the future, but I just want to highlight that because it's probably something you'll run into when you're using Firmata like this, and just unplug, replug the board, and you're good to go for this. So let's see, let's maybe run a couple more examples, and then we'll wrap up the stream. We're getting close to an hour here, so let's see, let's do real fast. I'll just kind of run through some of the ones we haven't done. So cap touch, the capacitive touch. Again, I have two examples. There's captouch.py, which is like the accelerometer. Maybe we'll look at the code first, where I have a read cap touch function, and just every 2 seconds I call it, and it'll just print out the state. So let's just run that one real fast. So we'll do Python 3 captouch.py and my USB modem device, and this will run. And you'll see this one listens for pin 10 on the side here, and it just prints out. So what happens with capacitive touch, you get a raw numeric value back. So like this one's coming back, and every 2 seconds it's saying 0. Now, if it might see some noise, like you see like 2 or something like that. Now I'm going to press my finger on input 10 right here, and now watch this. So it's getting a value like in the thousands, 1024, 2602, and it's actually saying that button is pressed. And if I let go of this, you see it goes back down to 0. And then if I touch it again, it goes back up to a high value. And so this value, again, it's kind of meaningless. Like it doesn't have any units. It's actually the number of cycles that it took for a high level to fall back to a low logic level. And that's because when I touch this, I'm actually changing the capacitance of the input. And then there's a resistor that's put in a special configuration, an RC filter, that kind of slows down how a signal changes based on the capacitance. So the more capacitance, the slower it takes for a signal to change. And so it's reading how long it takes for that signal to change. And so when nothing's touching it, very low capacitance, so that signal immediately falls back from a high to a low level. But when I touch it, I increase the capacitance, and then it takes a little bit of time for that signal to fall down. And you pick that up and you see a higher cycle count. And then you just assign a threshold. So I think I have the threshold set at 300 right now as a default. And so, if it gets above 300, then I kind of say, okay, something must be touching this. And you can actually do, you can put like an alligator cable. So let me grab some of these. You can connect a wire to this, and then you can touch the wire. So like, little alligator clip, I'll put that on pin 10. And so, really easy to use Circuit Playground like this. You just put an alligator clip on here. And now whenever something touches this clip right here, the end of this clip, we'll see the capacitance changes. But it's kind of interesting, just connecting that wire and me kind of holding it like this, like, my finger touching the insulation, that kind of changes capacitance a little bit. So, just the wire alone, it increased the value, but it's not above that threshold yet. But then if I touch the little metal part of this, you'll see that, okay, now it's up in the 800s and the button is pressed. So really cool stuff you can do with capacitive sensing like this. You can set up like a bunch of objects. Like you can actually connect this to something metallic, like a sheet of tinfoil, or like even something that's conductive, like a piece of fruit. That's like kind of the canonical capacitive touch demo. You get a bunch of bananas and oranges and apples, and you put little alligator clips on them, and then when you touch that fruit, your body changes the capacitance of it, and you can pick that up as a capacitive touch sensing kind of input here. So that's the basic demo. Like I mentioned, you call read cap touch, it will call a callback function for you, and that's what I've defined ahead of time right here. And this will actually tell you, here is the pin, like the pin number. Here is if it's touched or not, if this is a true or false, a Boolean value. And I just have a threshold in the library that I set. It's actually in the circuitplayground.py file. It's one of these values up at the top, I want to say. Somewhere I had this threshold set. Let's see, oh yeah, here it is, cap threshold 300. So if you wanted to change this, you can actually change this in your code. But anyways, so that'll give you a Boolean. So if you only care about was it touched or not, just look at that Boolean. But it also gives you the raw value, like maybe you want to apply your own threshold or do whatever. And so that's what this callback is doing. So that's the basic example. And then the streaming example, just like streaming of the accelerometer data, there's a start cap touch and a stop cap touch. And you pass it the pin number that you want to listen for, and then it'll stream, and you give it a callback function again, exact same callback function. So it'll tell you the input that was touched, and then it'll tell you was it not touched or touched, like that Boolean value, and then it gives you the raw value. So we'll run this example. This one basically runs for a few seconds listening to pin 10 again, and then it'll run, because you can set up multiple pins. You can have up to 8 of the inputs as cap touch inputs. So then it'll listen for pin 3 and 10 and print those out. So let's do this demo. So we'll do Python 3 cap streaming dev tty.usb modem. So we'll let this run, and let's see, this should print out, and it'll print for 2 seconds. You'll see kind of the raw values, and then so yeah, it goes for 2 seconds, then it pauses for 5 seconds, just kind of demoing that you can start and stop the streaming, and then it's going to run for a while. So now it's showing both pin 3 and 10, and it's a little hard to read here. And actually here, let's change this function. So instead of printing out the raw values, we'll just print out only when they're touched. So that's a little bit less noisy. So now let's run this example again, and we should see that this works. And again, this code, I use the little finally clause and I stop the CapTouch streaming, because you can have the same problem where if you started the streaming and then quickly exit, it's going to keep streaming and you try and reconnect and it'll fail. So just something to be aware of. So okay, so now it's listening for pins 3 and 10. So like if I hold 10, look at that, CapTouch 10 is touched. If I press 3 over here, 3 is touched, and I can do both of them. So 3 and 10 are kind of pressed at the same time. So that's cool. It's real quick, very fast. This updates every 20 milliseconds or so. It gives you kind of new readings for that. So great little demo of that. Lots of possibilities, like I said, with capacitive touch. So okay, let's do maybe one more thing real quick, or I guess a couple. I think we've almost gone through all of these now. So let's look at the tones. Yeah, tones.py, and I need to give this dev.tty.usb-modem. And so this is going to play some sounds on the little buzzer, the little speaker that's connected to the Circuit Playground. So I'll pull this wire aside for now. And it'll take a second here. So here, I'll hold this up to the mic. Cool, so that's it, basically a little scale. So let's look at the code for that. And you can hear, it's not the prettiest sound, but it is sound. And you can make, music, songs, all kinds of stuff with that. So let's see, tones.py. Let's look at this one. So again, same boilerplate, import the library, create a Circuit Playground object. Now here I create a scale, which is just the frequencies of these notes. And I said it's a C major scale. I was just looking at like Wikipedia and sites like that. So like 262 hertz, 294 hertz, 440, I think that's an A4. So, these are just the frequency in hertz of these music tones. And like I said, it'll play a little square wave to make that sound. And then there's a duration for each note. So half a second, 500 milliseconds. And then I just go through in a loop and I call board.tone, and you just say the note, the frequency, basically the frequency in hertz, and the duration in milliseconds that you want this to play. So this will go through and do 262 hertz for 500 milliseconds. And then it'll delay, and I delay for like, I think I take a quarter or tenth of or so of your duration. So I pause for a small amount of time, and then I go on to the next one. So then I do 294 hertz for 500 milliseconds. So a real simple, easy way. You can pass in, the frequency and the duration. And for duration, these are both 14-bit values. So you can go up to like 14 seconds or so, I want to say, of duration. So pretty long duration. Now, I also did put in a way you can just call board.tone and only pass in the frequency. So like pass in, 262 or 440, and don't pass in the duration. And now the buzzer will actually start playing that tone, and it won't stop. It'll just keep playing. And so you want to be careful. Like in this code, I sleep for a second, and then I call no tone, and that will actually stop playing any tones. But like what if I press Control-C and quit my program? Well, my board's going to keep playing that tone, and my computer is not connected anymore, and it's not there to say, hey, stop playing that tone. So it's just something to be aware of, that be careful when you do tone playback. That's why in most cases you probably want to give it a duration so that it doesn't get stuck playing a tone. And when you reset the board, it will stop playing tones. Like it goes into kind of a default state there too. But just real quick, easy demo. One function call, play a tone. It doesn't have to be super hard to do stuff like that. It's really cool. So okay, I think we have time for one more demo then, and let's do. How about the tap detection? So let's do the tap streaming. So again, there's two versions of tap detection: tap.py and tapstreaming.py. Tap.py is just like the others, where I have a function you can call, and it'll tell you, do like a one-time reading. The trouble is, the tap detection, there's a little register that's updated with the tap detection state, and if you don't call a function to check that tap detection state, pretty much as soon as that tap happened, you're going to miss that event. And so in most cases, you want to use this tapstreaming.py, because this will turn on streaming of tap detection state. So the board is just constantly going to be sending you, here's the tap detection state, and that will quickly pick up on, when you tap the board and when you don't tap the board. So it's just I wanted to show both of those examples, but in most cases you want to use the streaming example just because it's going to be faster and it'll pick things up. So all right, so we'll do Python 3 tap streaming, and let's do dev.tty.usb-modem, and we'll run this, and Just like the other streaming examples, it runs for 2 seconds, pauses for 5 seconds, and then runs forever in a loop. Because again, it just shows off. You can start and you can stop streaming the tap data. So pausing for 5 seconds right now, and then in a second here. So now it's waiting for tap data. So now I'm just going to tap the little sensor in the middle of the board, the LIS3DH, and we'll see what happens. So when I do like a single tap, now you can see it actually gets 3 events, and so there's a little bit of noisiness here, because like it's hard to define like what is a tap, and you can actually change the sensitivity of the tap detection in this. You'll see there's a function to do that, but just something to be aware of that, it's not always perfect. You're not always going to get like one event for one tap action. So in your code, you might want to do something like when you detect the tap event, do some action and then ignore tap events for like the next, 30 milliseconds or something like that, so that you don't get like double taps and stuff. And the board actually can differentiate between a single and double tap. So I'll press it twice. So when I do that, so you can see, and it actually got a single tap event because the first tap that I hit is a single tap, and then I quickly tapped it again, and then it got a double tap event. So just something to be aware of also, that you can get double taps, which will probably also trigger a single tap event here too. But pretty cool. And actually, if I tap next to the board, in some cases, if I tap strong enough, you'll see it kind of picks it up. So it works best when you tap the sensor itself. And oops, I just pressed the reset button. So now I just broke the sketch probably because I severed the connection. Yeah, the serial port died. But anyways, I mean, you see the basic idea there. So you tap the board, and I'll show you the code for this real quickly. Tap streaming.py. So basically, exact same boilerplate setup here. Create the Circuit Playground object. Now there is this set tap config function that you can call, and I have a big description here about why you might want to change this. So this lets you control the sensitivity of the tap detection. You can actually, this first value should be 0, 1, or 2, and the default is 2, which will detect both single and double taps. If you only care about single taps, you can just pass in 1, and it'll only listen for single taps. And then the second value is the sensitivity or the threshold. And the lower this value, the more sensitive that it is. So, right now, maybe I have it a little too sensitive because you see like these 3 events here. So, let's increase it. Let's just see if this helps a little bit. So let's bump this up to like 120, and we'll save this. And it also mentions here, this depends a little bit on the range of the accelerometer, and I have this little table here. So if you change the range of the accelerometer, which in the accelerometer streaming.py example, it shows how to do that, you might need to change your tap detection. But the actual tap detection, there's a start tap, and then you give that a callback function. So this callback will be called anytime there's new tap data, and basically it just gives you 2 booleans. So if single is true, then you got a single tap. If double is true, you got a double tap event. It's as easy as that. There's not a lot of craziness. You can stop tap streaming, and then in my loop I just turn on tap streaming and just wait and do nothing. So let's save this, and let's see. We should, in theory, this should be a little less sensitive now because I've increased the value. So let's see if we get as many tap events. I haven't really played much with the threshold value here, so it might not change anything. We'll see. Live internet. So okay, so it does its thing for 2 seconds. It's going to wait for 5 seconds. So we'll give it a second here to go. And then okay, so now when I tap it, okay, it seems it's a little bit more sensitive. Like before, I just lightly tapped it, but now I really have to kind of press it. Oh, and I just pressed the reset button on accident. You can see it flashing. So the threshold does work. You can make it more or less sensitive if you want to taps. So okay, I think that's all I've got time for. I'm running a little bit late on time here, so I just wanted to run through the examples. There's a couple other I didn't show. There's a temperature example. This is very simple to the light sensor. The sound example, this reads raw microphone samples and prints them out. So it's very simple, very similar to the light sensor example. So let's see, if folks have questions, throw them into the chat real quick, and I will see. Let's see, I think there was some stuff earlier. So one question was, so for wearable, and let me change real quick to the main camera view. Let's do this, this, and this. So, okay, so question was, for a wearable or portable device, can we drive it from a Raspberry Pi? Yeah, you can definitely drive this from a Raspberry Pi. So, like I said, the Python code works in both Python 2 and 3. It'll work from the Raspberry Pi. You should just be able to plug in Circuit Playground and go from there. Actually, I just saw there's a build of Arduino now that works on Raspberry Pi. So, in theory, you could probably program Circuit Playground directly from the Pi if you install the latest Arduino for Raspberry Pi. and used like the Pi desktop environment, you probably want to use the Pi 3 because it's a little bit faster, but you should be all good to go for that. But even if you aren't using Arduino on the Pi, you could use Arduino on your PC, load up the Firmata firmware, and then connect that to your Pi, and then run like the Python code here, and you're good to go with that. So that seems good. And let's see, any other questions? Can you wire it to a Fona so it can be mobile? Fona is a good question. You can in theory, because the board itself, so let's see, let me pull it off here. Pin 0 and 1 up on the sides here, these guys, these are your serial TX and RX. So it can talk to serial devices, and Fona can act as a serial device if I remember correctly. And so, you could wire a phone up to those. It's an ATmega32U4, so that's like a Leonardo. It should work. I'm pretty sure the Fona library, it definitely supports like the Uno and the Leonardo, so I don't see any reason why you couldn't hook a Fona up to it. I think it would work in theory. I haven't tried it, but that's a really cool thing to try. How to get a Wi-Fi board. Let's see. Oh, has anyone figured out how to get a Wi-Fi board to grab any open connection? I don't know. I haven't seen anything like that. That's a good question. I think all of the Wi-Fi boards have like a scanning mode where you can say look for any access points. And I remember, like, I know the CC3000 at least does it, where it can tell you here's the access point, here's if it's open or not. So you could probably write a little library or a little function even that does your scan function, looks for open access points, connects to them. The trouble is, like, you're probably going to run into those annoying access points where you have to load up a web browser page and like log into something to connect to it, which I doubt a lot of the Wi-Fi boards handle very well. Even like your phone doesn't handle this very well these days. So that's that. Let's see. Anything? So one question, didn't catch the beginning, but are you running a special version of Firmata? Yeah, so this is a special version of the Firmata firmware. It's one that I've modified to add some extra commands to. So like I mentioned at the beginning of the stream, check out when this goes up on YouTube. I'll have links to the actual Firmata code that you need to load up on here. So it's on this Circuit Playground Firmata repository. There's a little sketch here, and I showed earlier in the stream how to load this up. So that's that. So okay, so I think that's the end of the stream. I'll wrap it up. So thanks a lot for watching. Subscribe to youtube.com/Adafruit. You can watch this video and all kinds of other fun projects. Subscribe to twitch.tv/Adafruit. You can watch me stream this stuff live. This is kind of a quick little off-the-cuff stream. And like I said before, if you're interested in Circuit Playground, actually someone in the chat just said that it's live now. So maybe check adafruit.com right now. But definitely check Ask an Engineer tonight. There could be some interesting stuff on the new products segment. So check that out. Like, comment, subscribe, do all the happy stuff that keeps us going and doing all these great videos. And then check out this Friday, I'll do a new Raspberry Pi Wi-Fi, talking to Wi-Fi things series video. So we'll look at how to talk to Wi-Fi boards from the Pi. So that's it. That's Tony from Adafruit, and I will see you guys later. I'll see you guys Friday. And have fun. Check out Circuit Playground and the Firmata sketch. Program it with Python and high-level programming languages. So that's